Chapter 8, Water and Minerals. There's a lot in this chapter, but I'm only covering calcium, sodium, and iron in this lecture. But first, a word on water. Water is our most important nutrient. It makes up about 60% of an adult person's weight. Getting enough water can be a challenge. The DRI recommends 13 cups per day of water for men and 9 cups per day for women. This makes up about 80% of what you need for your body, and foods give us the remaining 20%. The bottled water industry has helped make drinking water more popular, and it's also emptying consumers' pockets. According to the Beverage Marketing Corporation, the value of bottled water sold in the United States during 2006 was about $11 billion. Instead of filling up a reusable water bottle with tap water, Americans are buying cases and cases of bottled water, thinking it's healthier and safer to drink. But when the National Resources Defense Council tested 1,000 bottles of 100 brands of water, their report showed more than a third were contaminated by bacteria, arsenic, or other synthetic chemicals. Go to the External Links folder and click on Bottled Water to check out the details on your favorite bottled water. There are actually stricter standards for tap water than there are for bottled water. The Consumer Corner on page 271 gives more details on bottled water. Starting with calcium, our most abundant mineral in the body. Most of our calcium is stored in our bones. Only a very small amount is in our bloodstream, and our body regulates this very carefully. If our intake of calcium is low, our body responds by increasing the amount we absorb. Our body also responds by decreasing the amount we excrete in the urine. And to maintain a constant level in the bloodstream, our body will draw calcium out of the bones if needed. Remember, that is vitamin D, which regulates blood calcium. It's important to maintain blood calcium within a certain level, because calcium is important in nerve transmission, blood pressure, blood clotting, muscle contraction, and other cellular activities. This is why you can't simply take a blood draw and measure your level of calcium. When we don't get enough calcium, our bones suffer. We spend the first 18 years of our lives trying to build up adequate bone mass. After about 18 years of age, we continue to build up some bone up until the age of 30, at which we have achieved our peak bone mass. After that, it's all downhill. We start losing our bone mass year by year, and it is accelerated during menopause for women. For those that did not achieve adequate peak bone mass, there is the risk of developing osteoporosis. If you look at this picture here in your book on page 305, you can see that woman B, with the lower initial peak bone mass at age 30, has slipped into the danger zone before age 60 and then develops osteoporosis even before the age of 70. Osteoporosis is the reduction in bone mass. In this picture here on page 304, you can see the differences between the healthy bone and the osteoporotic bone. The bone with osteoporosis is very thin and brittle. The consequences of osteoporosis are broken bones. About 1.5 million suffer broken hips every year due to this, and 20% of these individuals die. The goal is prevention, but you have to start early. Milk is not the only source of calcium. Although with the amount of commercials we see advertising milk, you would think that milk was the only source of calcium. But this is not so. You can obtain all the calcium you need with other sources. The problem is many of these sources are not as appealing as milk or dairy products. Dairy products are a very easy way to obtain adequate calcium. Recommendations for calcium are about 1,000 to 1,200 milligrams per day. Milk has about 300 milligrams of calcium per 8-ounce glass. But the calcium in milk is only absorbed at a rate of about 30%, so you'd only absorb 100 milligrams of this calcium. It's okay, the RDA took this into account. But what I want to point out is foods like broccoli, turnip greens, and bok choy, oh, I know your mouth is watering right now, have a calcium absorption rate of about 50%. At an absorption rate of 50%, you can see that 1 cup of cooked bok choy or cooked turnip greens have more calcium than a glass of milk. The turnip greens listed in your book are fresh turnip greens. That's why the value is different. Sodium is the major extracellular ion and maintains fluid balance in the body. When there's a high level of sodium, our thirst kicks in, so we drink more water and the volume of fluid in the blood increases. This is why sodium has an impact on blood pressure. The upper limit for sodium intake is 2,300 milligrams. As you can see in this diagram here, also on your book on page 280, is that most men and women obtain much more than even the upper limit. Let's look at a few sources. Here's the nutrition information for a half cup dry mix of pudding. The sodium in a half cup is 375 milligrams in a half cup. Now let's compare that to a half cup of dry roasted and salted peanuts. 228 milligrams of sodium. That's less than the pudding. How about Ritz crackers? 1 ounce, the same weight as the peanuts. It's 217 milligrams of sodium, still less than the pudding. Remember from our earlier chapters that sodium will increase the sweetness of foods. That's why you'll find a higher sodium content in a lot of processed dessert food. Okay, now let's move on to the more obvious culprits. Now what if you had breakfast with the king? A sausage, egg, and cheese crisp sandwich from Burger King. That's 1,037 milligrams of sodium. And what about the meat lover's pizza from Pizza Hut? 1 slice is 840 milligrams of sodium. So to be realistic, we have to say that most people have at least 2 slices. That's 1,680 milligrams of sodium. And some people even have 3 slices. That's a whopping 2,520 milligrams of sodium. That exceeds the upper limit for sodium in one meal. Lastly, I'm going to cover a few things on iron. The reason iron is so important is that it is part of a protein called hemoglobin, which carries oxygen in our red blood cells. In this diagram here, also on page 183 in your book, you can see the iron within heme, which is part of the hemoglobin protein. There are 2 types of iron, heme iron, seen here, and non-heme iron, which is found in plants. Heme iron is more absorbable than non-heme iron. Heme iron is absorbed at a rate of about 23%, and non-heme iron is absorbed at rates of a low of 2% and a high of about 20%. The factors affecting absorption include vitamin C and MFP factor increasing absorption, and coffee, tea, tannins, phytates, calcium, phosphorus, and fiber decreasing iron absorption. To better understand this, let's look at this picture of chili. It's also on page 290 in your book. Iron comes from the beef and the beans in this chili dish. The tomatoes have vitamin C, which increases iron absorption, and the MFP factor in beef increases iron absorption. But the beans also have fiber, which inhibit iron absorption. Even with fiber, overall, this meal is an excellent source of highly absorbable iron. Okay, that's it for this lecture. I can say that you've now completed the most difficult part of this class. Well, you still have the diet study project, but we've completed what students feel is the most difficult material.